All right, so introducing our next person, we have Anika Pent, or I think I pronounced that right, and she's explaining building and coding EV3 robots using the Virtual Robotics Toolkit.
Hi there, Vlad. Thanks for having me. Great, Vlad. Cool. You're seeing my screen okay and hearing me all right also?
Yeah.
Awesome.
As far as we see in the Zoom call, it should be live streamed to YouTube, but I would need to check that.
Great. I just wanted to quickly introduce myself. My name is Anika. I'm from First Robotics Canada. I'm joining you today from Toronto, Ontario. It's about 7 at night here. And at First Robotics Canada, I'm the programs coordinator and really excited to be here to let you know about the Virtual Robotics Toolkit, which is a really powerful tool by a company called Cogmation Robotics that a lot of our teams have been using here. And I'll tell you a bit more about it. It's a robotics simulator, and it was designed for use with LEGO Mindstorms. And what's great about it is that it allows users to design, build, program, and test virtual robots without the need for physical equipment or space for testing. And some of the reasons why folks might decide to use the Virtual Robotics Toolkit, especially if you're on a First LEGO League team, is that you can, team members can train and develop their skills during the off season and actually during the season as well, because some of the virtual environments in which you can program and test these robots are the actual playing fields from the First LEGO League Challenge competition. And you can use 2 different types of software to program the EV3 robots in Virtual Robotics Toolkit, one of which is MakeCode by Microsoft. And although not identical to, it's similar to the blocks programming tool used by FTC teams. And for any FRC teams that are working on outreach or coaching First LEGO League teams, again, this is a great training and skill development tool. Participants can compete in or host virtual competitions, and it's also great for people that don't have access to physical LEGO Mindstorms EV3 robots and people that are sort of far away and can't necessarily get to a competition. One of the limitations, though, is that so far the software is only available for PC and Mac operating systems, so not yet web-based, so can't be used on, like an Apple device or a Chromebook.
What about Linux? Sorry for interrupting. Just wondering, what about Linux?
Same. Yeah. Thanks for checking, Vlad. And yeah, please let me know if there are any other questions. I can't actually quite see the chat from where I'm presenting, so please let me know if there are any. And these are the different types of software that you would need to use the Virtual Robotics Toolkit. One is the LEGO Mindstorms Lab EV3 Lab software. If you want to actually design and build virtual robots to import into the Virtual Robotics Toolkit, you can use the LEGO Digital Designer or LDRAW to actually make the robots. And no matter which one you use, you do need the LDRAW library, because when it when the robot is imported into the Virtual Robotics Toolkit. I guess that's the repository of Lego components that it uses to transfer over. And all of these software are free, or Virtual Robotics Toolkit at least is free for 60 days. So if anyone is interested in trying the software out to see if they like it, the company Cogmation Robotics is offering 60-day complimentary access at the link that's shown here. And Vlad, are these presentations being made available to folks after the 24 Hours of STEM Festival?
Yeah, I believe so.
Okay, so so the link will hopefully be there if you check the recording and that's something that you want to check out later. And then to get the 60-day complimentary access, there's an activation code there as well, the 16-digit code. Is it 16? Yeah. So that's how you can try it out if you like what you see today. There are a variety of different virtual environments in which you can program and test the robots. I'll be showing you predominantly one today just to introduce you to the user interface and some of the, I don't know, features and applications, but there are a whole bunch of different ones from which to choose. And maybe most importantly for this audience is as I mentioned, the different First LEGO League game tables, including City Shaper, and I think Cogmation is working on the replay challenge mat for the 2020-2021 season. So in this afternoon session, I'm just going to quickly introduce you to some of the different ways that you can actually move the robot around in the virtual environment. One is just using the keyboard keys. And the other is using the LEGO Mindstorms EV3 Lab software. And the third one is using the Make Code software by Microsoft. And when I get into that environment, just wanted to mention that there's different key combinations that can allow me to change the view. So I'll show you what that looks like as well. So I've just come out of my presentation and hoping that folks can see the first environment here. This is the Virtual Robotics Toolkit. This specific challenge is called the Cleanup Challenge because the goal of the challenge is for the robot to actually push these blocks off the tower. And again, students that are using these might find it more useful to program robots in the first LEGO League challenges, but this will just give us a chance to see some of the different things you can do in a simpler kind of environment. The first way that you can move around the robot is using the keyboard keys. So to start this simulation, I'm going to click on the Start Simulation button at the top. And there's no programming required for this component. This is kind of like the teleop portion here. So I'm going to use my W, A, S, and D keys to try and drive the robot towards the tower and then, push the bits off without the robot itself driving off the platform. And you can continue to do that until all the pieces are off. And as you can see, I've got stuck. So that's sort of the end of that round. I'm going to stop the simulation and it'll reset. Again, goal is to try and knock off the pieces of the tower without the robot itself falling. But what I'm going to do quickly is show you as well that you can attach different things to the robot to try and make that job easier. So I'm going to just go to the top and click on Attachments. And I think I'll select maybe this V-shaped shovel. You can see that it's been added to the robot in the simulator here. I'll just add it in my attachment manager as well. And I'll start the simulation again and just see if I have any more success with this attachment here. So that worked a little bit better. Still got one more to go. Might happen for me on its own. Awesome. So that was a quick demonstration of how you can use the keyboard keys to complete the challenges or move the robots around in these environments. You can see that it took me 15 seconds to do that. And there are challenges or environments in which you can actually record your scores and see how they measure up against other people that are participating in these challenges. So I'm just going to come out from here, and these are some of the places where you can find the other types of challenges. I'm going to open the same one, but with a different robot, and show you the next way to get it moving, which is using the LEGO Mindstorms EV3 Lab software. Great. Okay, so in the right side of my screen, you see the canvas for the EV3 software. And I'm going to quickly create a program that does pretty much the same thing as the previous program or the previous simulation that I showed you. I'll try and program the robot to drive forward till it's kind of in line with the platform, with the tower, turn towards the tower, and then drive a little bit farther so that the pieces get pushed off. And I'll just zoom out here a tiny bit so you can see the full platform as that's happening. To do that, I'm going to use blocks at the bottom, and the main one that I'll use is called Move Tank. And I'm going to actually grab 3 of those and put them in a row, but I'm going to change the conditions in each one so that the robot performs 3 different behaviors. In the first portion of the program, I'd like the robot to travel forward a little bit until it's side by side with the tower. And so to do that, the wheels or the motors are going to need to rotate a certain number of times. My guess is that it probably takes about 2 motor rotations to get the robot to be up in a position that I want. And the 50s here represent the amount of power that's going to the motors, and that impacts the speed. And so this first block is just driving forward, and the wheels turn twice. In the second block, I want the robot to turn to the left. And so I'm going to make the left wheel spin in reverse by changing this condition to a -50. And this value here is how much the wheels have to turn, the motors have to turn to get my robot to turn 90 degrees. So I'm going to predict that it's going to take about 0.6 wheel rotations, and we can test this out and adjust as necessary. This is just trial and error, and there are ways that you can be more specific about it and actually measure the amount so that you don't have to guess. But just for today, once it's turned and faced the tower, I'm going to get it to drive forward an estimated amount so that it gets to the edge of the platform, but itself doesn't drive off. So let's try 5. So I want to next get this program onto the virtual brick. This is the same display as you would see on a physical LEGO Mindstorms EV3 robot. And the way I'm going to send the program over there is to click down here and connect them up. So the robot here on the left is called EV3 Educator Vehicle. And you can see that if I hover over this, this is the download button. So hopefully you heard that sound. That means that the program has been downloaded, and I'm going to use the brick buttons to navigate to the program. It's in a folder called First Canada Live. And so I use the center brick button to get into that folder, and then scroll down to the program called Drive Turn. And then let's run it and see what happens. All right, So 2 might have been a bit much, 2 wheel rotations. It went just a little bit past the tower. And so I might change that, I don't know, to a 1.8. I could reset this and try it again. I would just run it straight from the program instead of downloading it and searching for it in the file menu. That one was a bit better. But again, you notice there's one cylinder left there, unless it rolls off by itself. I can't really do much more with this. So you can create smarter, more efficient programs that actually detect the things that are lying around and look for them and actually drive towards them and push them off. So I'll show you quickly a program like that, just to show you that you can also use the different sensors that come with the LEGO Mindstorms EV3 core set in the same way as you would with a physical robot in the virtual environment. So in this program, it uses a couple of loops and switches. And the main idea is that the robot just sort of turns and it's scanning the environment for anything that's within 100 centimeters of the ultrasonic sensor. And if it detects something within 100 centimeters, then it'll start to drive towards the obstacle or the object. And then it'll keep driving until one of 2 things happen. Either it's the color sensors see that the robot is still over this sort of black and red majority of the platform, or the color sensor will detect this white border. And if it does detect the white border, it will sort of back up away from the border so that it doesn't fall off, and it'll start that sweep again. It'll start looking for some objects and repeat the loop. So I'm going to just send this program over and see how that works as well. So you can see that it's doing its sweep once it got to the edge. And there we go. So it detected that there was something else in the way. I'm not sure why it's not picking up those 2 cylinders that are lying there. It may have to do with the positioning of the ultrasonic sensor, in which case I could actually modify this robot in the LEGO Digital Designer and try the program again. But hopefully that gives you an idea that the sensors work in the virtual environment in the same way as they would in the physical robot. All right. Just wanted to check in with the group and see if there are any questions. Everything okay so far, Vlad?
Questions would be Mira, not me.
Cool.
So I'm not sure if she's here. Mira, are you?
No problem.
Yeah, we do have a couple questions.
Thanks, Mira. Sorry, I can't see the chat. Thanks for helping.
Yeah. So we have a question asking, how can we organize the virtual programming when the team is remote? Do you have any input on that?
Yeah, I'm not. So as a coach, I'm not sure what you mean by organize the programming, but because it's possible to share programs, I would probably recommend like a really good naming system for the files. So for example, who created it and maybe when it was last updated. You can annotate it and add notes to the programs. So just keeping really good records of what was done and on what date, so that if you're sharing it forward with someone, they can continue on, and you also have previous versions in case something goes awry and you need to revert back to a previous version, as I'm sure we've all had to do. Yeah, and so like when I was envisioning this for some of the teams that I work with, it was you know, say we four are on a team and I'm working on one program, we could either, like we could all be working on it live. So if I could screen share and you could tell me what to try and we could work on it at the same time while one of us actually does the controlling, or I could send it forward to you for you to work on at a separate time. I don't know if that answers the question, but.
Yeah, I think it does. And then we have another question. Are there existing table mats available in the Mindstorm software? So I assume that means like for like FL games that like already exist. Like can you use a pre-existing mat?
Yeah, let me open, I'll show you which ones are available. I'm gonna not save this for now. And that's what I want to do. Okay, so let me close my brick here as well. You see here there's an FLL option or First LEGO League option. And these are the 4 that are available. So going back to 2016, we've got Animal Allies, so you can read them. I'll just open City Shaper. I was reluctant to open it because I know sometimes these ones are like a little bit more like graphics intensive. And so they sometimes take a bit longer to open, but let's just check it out so you can see how close it is. And I know that the developers at Cogmation are really careful about programming the physics of these mission models so that they behave like quite similarly to, obviously not exactly and not perfectly, but it's really great for doing strategy, right? So if you're trying to be efficient in terms of which missions to do and in what order, this is a great way to test it. And even a lot of the programs, if you program a robot to complete a mission in the Virtual Robotics Toolkit, you can then just test it on your physical robot. Of course, the robots have to be built identically, both virtually and physically, for them to be able to match up like that. So yeah, you can see that this one's taking a long time to open. While it's doing that, I'll just mention that the next thing I'll show you is how you can also program the virtual robots to do the same thing as it did in the previous 2 methods, but using the Microsoft MakeCode, which again it's maybe more similar to what people are used to using, like Scratch and as I mentioned, the FTC programming tool. This is taking so long.
Someone just asked in chat here, does it support the MicroPython interface?
Not right now. Yeah, and it's great feedback because I'm always in communication with Cogmation, the company. We just use this. They're the ones that make it. So I'm always interested to pass on suggestions that would allow it to be more useful for lots of users.
Okay, so that's all the questions we have right now.
Thanks so much
for answering those.
No worries. Hope it helps, and good delay while this thing loads. So again, this is I don't know, for any of you that have seen the City Shaper field, it looks pretty similar. We've got our some of our elements over here, and again, you can zoom in and take a look at some of the different missions. Again, the robot that is shown here is just a generic one that's there, and there's not much you could really do with this robot because it doesn't have the same kind of customized attachments that a physical robot would have, which is where the Lego Digital Designer comes in, because you really want to make a robot like the physical one that you would want to be using in competition so that it behaves in the same way and that you have the same mechanisms and so on when you're programming. All right. Going to quickly go back into a slightly simpler virtual environment just to show you this last method by which you can move the robot around. And that's using the Microsoft MakeCode. Hopefully this one doesn't take quite as long. maybe while that's happening, I'll show you the Lego Digital Designer that I've mentioned a couple of times. This is the user interface, and I've just, I haven't built this robot from scratch, although I could have, because there's basically a virtual library or repository of all of the Lego components, and you can, I've filtered them just so that the pieces that come with the Lego Mindstorms EV3 core set and expansion kit are available in my library here to the left. So I could have built this robot just by starting with those pieces, but a lot of there are a lot of I don't know, pre-built models available online that you can import. And so if I liked this base model or this chassis, I could import it, which is what I did. And then I can add and remove pieces to kind of customize it, just so that you don't have to start from scratch. But this is a neat tool. You can take pieces off and change their orientation and position and so on. And you can also select components from the library here and add them on if they fit somewhere. So you just have to make sure that they that they fit. And then once you actually made a model in the Lego Digital Designer, the cool part is that you can create a building guide. So someone else could virtually or digitally build the same robot. And it shows you what pieces you need and in what order to attach them. So that's a pretty cool feature. And then the other great thing is that you can take whatever you design in Lego Digital Designer and import it into the Virtual Robotics Toolkit. And that process is a little bit, I would say that process is a little bit more elaborate, and it takes a bit more time. So I won't show you the full process for importing, but to just show you in the Virtual Robotics Toolkit, there's the import option here. And while I was showing you that, you can see that this environment has opened back up again. So I'm going to show you how you can move the robot in one more way. But first I have to get out of what's called Advanced View. There are just two different views, and to get out of Advanced View, I'm going to click F12. And to get the MakeCode user interface to show up, I just have to click a couple of things here. I'm going to first enter into the split screen mode. And I don't want EV3 anymore. I would like MakeCode. So I'm going to click F8. And this information is available on the Cognition, in the Cognition user guide, which is linked in the resources at the end of this presentation. So if you miss any of these shortcuts, like F12 to change the view, or F8 to get MakeCode going on, then you can refer back to that. But I just need to split my screen again. There it is. So you can see down below, it's sort of split horizontally instead of vertically now. I've got a program that I created ahead of time called Drive Turn, and it's designed to do the same thing as one of the previous programs that I showed you. Just drive forward a certain number of wheel rotations so that the robot is aligned with the tower, turn to the left, and then drive forward some more until the robot pushes off the pieces of the tower without itself falling off the platform. So in MakeCode, as in something like Scratch, which you've probably used, you'll know that there are different categories of blocks, and all of which are available here. Different motors, different motor blocks, sound blocks, and so on. And you can go through all of the different categories. So just showing a very simple program. So when I click Start, both the motors that are plugged into ports B and C are going to rotate 1.5 times. then one wheel is going to spin backwards and one forward so that the robot does a left-hand turn, and then drive forward another 5-wheel rotation. So I'm going to click on play, and hopefully it will behave in the same way as in the previous program we created in the LEGO Mindstorms EV3 Lab software. All right, so it came up a little bit short. Just change a few of these and see if that makes any difference. And run it again. Better that time. Awesome. Okay, and again, using different combinations of blocks, we could make more complicated programs using the sensors and loops and switches and so on to make the programs work a bit better. Yeah, and great question from Vlad. It does have a sort of simulated randomness to make it more like the real world, because as we know, you can run a program on the exact same robot and it turns out much differently from the previous attempt. So yeah, the developers have programmed in some randomness, which is, you know, frustrating but realistic. So great question. All right. So let's come up from here. And let's see where we are. Okay. Yeah, I did mention that once you figured out how to move your robot in a whole bunch of different ways using your method of choice, and once you learned how to position your view in a way that works, you can also design and build your own robots using the LEGO Digital Designer, which I showed you. And as I mentioned, you can either build models from scratch, or you can download and modify existing models and then import them over into the VRT so that you can complete the missions, especially in the first LEGO League challenges, in a more realistic way using the mechanisms that you would normally use on a physical robot. And also, as I mentioned, you can create a parts list and also building instructions so that other people can make the same robot as you have. Of course, you could also just share the file with them so they don't need to rebuild it. But that reminds me of the previous question about if you have teams that are working remotely, it's a lot of file sharing and a lot of organizing in terms of where are you going to keep the programs and keep track of when they've been updated and in what ways. A very new logistical consideration for these times in which we're all working remotely.
Another question we have on like a similar topic is, is there one programming environment that can be like shared instead of everyone individually working on their own laptop?
Do you mean like, is there a web-based version where you can?
Is there a way that like multiple people can be working on a program at once? I think that's what it's asking.
Yeah, I mean, I don't think the software is set up for that, but the only way I can imagine is if say you and I were working on a program, is that there's a way for me to give you control of my keyboard at the same time as I do, and so we could be, I suppose, clicking and dragging different blocks all on the same time. But I think it would be more like, if you were working on your laptop, I might say, oh, grab one of those blocks and change the condition to this and see what it does. And I would be kind of watching and providing input as opposed to both modifying it in real time, if that makes sense.
Yeah, I think that answers the question.
Bit of a drawback, right? It's not like we can all be in at it at the same time. So yeah, it may be a limitation that makes it more challenging to do, but if you can see a way to make it work, then I think it's still kind of a cool tool. And and aside from using this for first LEGO League training and skill development, which I think is probably one of the best uses, it's also just fun to participate in some of the different challenges. There's like a sumo challenge, and there's a maze, and there's a challenge where there's like Lego bits all over the floor and you have to vacuum them up. So if people who are using this want to just get used to it or try some of these challenges, you can very soon we'll be able to save your scores and see how they rank on a leaderboard against people all around the world, I suppose, who are using this as well. Oops, sorry. There are, I mean, this is more for coaches or FRC teams, or I mean, I guess anyone, but if you're looking for a way to really, like, not really sure where to start, there are some courses, so you could go through the lessons one at a time to get used to using both the EV3 lab software, but also the virtual robotics toolkit. And there's different activities that users are invited to complete until they get really familiar with all of the features and applications of the two types of software and how they interface with one another. So this company, Robots Got Talents, has created the STEM Hero course that you can access at the link here. And once you go to that website, you can actually, sign up for the course, and you also get this user guide, which is pretty useful as well. And then just wanted to mention a couple of the different resources that if this is something that people want to use after today, they can check out these different resources for more information about the different features and applications that I haven't had a chance to really dig into too much more during today's session. The first one is, there's some learning activities. This is also interesting maybe for teachers, because they can do some math and science lessons using these activities. And it also gives you a chance to see some of the different environments that we didn't explore in much detail, like the sandbox and the maze and the vacuum challenge. So there's some activities there. They can be completed with or without coding. So again, the coding is probably the valuable learning piece, but if folks are just getting used to how to use the VRT, they can drive the robots around using the keyboard keys in these activities and still get some of the learning from there. There's also an individual who's created a whole bunch of tutorial videos that I've watched every single one and learned a lot from doing so. His name here is BuilderDude35, but he's, a young guy when he first started making these, and I think he's in college now. Those are really useful, so check them out. And then the company that made this software, the Cogmation Robotics, has also some video tutorials and a user guide. And then I've included here again the link to that STEM Hero course for anyone that wants to help guide themselves or others through it, like more step by step. Oh, okay. So I don't know how many people are on the call, but I'd love to find out how many people would actually want to try, after seeing this like brief taste of the virtual robotics toolkit, how many of you would be willing to A, try this software yourself, and or B, recommend this software to others? And you can participate in this poll by going to www.menti.com and entering the code 7886. And no pressure. If you're not having any of it and you're never going to try it again, that's cool too. But I'm hoping that this gave you a little taste of what's possible with this tool, and that you have some ideas about ways that you could take it farther and maybe benefit the teams or the youth that you work with. I'm just trying the Menti as well to make sure it looks like it is, because some people have voted. I am highly likely to try this software myself again, and I'm going to keep recommending it. There we go. Thanks for participating in this brief poll. It's awesome.
All right, we have one more question for
Yeah,
you.
talk to me.
Will the new season map be out at the start of the season?
Hopefully, Cogmation. I mean, again, I don't work for them, but they've indicated that they usually get the challenge set at the same time as it's released for everyone, which is early August, and then their developers go to work on having to build it and try and again learn and program the physics of it. So previous years, it hasn't been out like right in August, and not even by like the first day of the school year, which in my province is like beginning of September. But usually by like our kickoff, which is mid-September, and then hopefully that makes it available for enough of the season that it's useful. But because those previous challenge mats are available, I usually recommend to teams that they just try those, try and program and build a robot, try and program it to do one of those missions, because that'll get them really familiar with all the other stuff that they need to know how to do. And then when it comes time to actually access this year's challenge, they've gotten all of that other learning out of the way, and they can just focus on the new missions. So hope that helps.
Yeah. All right. Well, thank you so much for doing this.